Point 4, explanations for quiz 2 questions, number 7, number 8. Number 7, when we calculate the limit of the ratio of two growth functions, we can always, here the question is, if we can always apply the Robitus rule or not. Yeah, that's the main question. Yeah. Another case versus this one, sometimes we can apply, sometimes we cannot. Here we want to see which one we should take. Yeah. Always or sometimes. Yeah. Here, let us use a formula to represent this Robitus rule in a simple way. Yeah. So when we take a limit of the ratio of two growth functions, f of n and g of n. Yeah. In calculus 2, there is a very powerful rule we can use. It is called a Robitus rule. Yeah. That rule gives us a powerful tool we can apply. Yeah. Because sometimes when we calculate the limit in the form of ratio of two functions, it could be very complicated. Yeah. It could be pretty hard sometimes. But this Robitus rule gives us a special way to do the calculation using the derivatives. Yeah. If you use the derivatives to do the calculation, you can greatly simplify the limit calculation. So that is the essence of Lobitas rule. Yeah. All right. If you can apply, you will have this formula. Derivative of f function, f prime of n, over derivative of g function, g prime of n. Yeah. So that is the Robitus rule. Okay? Yeah. But for the Robitus rule, there is a big condition you need to check. Before you can apply it, you need to check a big condition. All right, that is certain indeterminate form. Certain indeterminate form. Yeah, so this terminology, indeterminate form. Yeah, there are several possible indeterminate forms you can consider. Yeah. One, infinity over infinity. Yeah. The numerator function goes to infinity, denominator function goes to infinity. Yeah. 0 over 0. Indeterminate, because you don't know the ratio. How large? What is the simplified result of the ratio? Indeterminate. That's the reason we call indeterminate. Yeah. So these two forms we consider for this class. Typically, actually for this class, we only consider that one. We don't have the 0 over 0 case. Yeah. Because our growth function, think about it, we apply it on the growth functions. Growth function always goes to infinity, right? Yeah. So, although in calculus, there is another case you can consider. And in calculus, there are more indeterminate form you can consider. For example, infinity times 0, indeterminate. Infinity times 0, how large is it? You don't know, indeterminate. Yeah. Then 1 to the infinity power form, 1 to the infinity, that power form. All right? Yeah. So you can see there are several possibilities you can consider. But for our class, we only use that one. That's good enough. Yeah. All right. So that's the background for the Robitas rule. Next question is, can we always apply the Robitas rule? Yeah, with that background, your answer is false. Yeah. Sometimes we cannot apply. The reason is very simple. It may not be in indeterminate form. Yeah. The ratio of the two functions may not be in determinate form, right? So that's one situation. Yeah. So here, let me put it right here. One situation, the ratio, yeah, may not be an indeterminate form. So that's one case. Another case, even the ratio is an indeterminate form. Yeah. But there is another possibility. The limit of the ratio may not exist. Right? The limit does not exist. How can you apply Robitas rule? Right? The limit does not exist. Yeah. Right? Yeah. So that's another possibility. Yeah. But for this case, we know in this situation, we can use inequalities. The method based on inequalities to solve. Yeah. So we do not use the limit to solve. We use inequalities to solve. All right? Yeah. So that is the question number 7. Yeah. Next question, number 8. If the limit of the ratio of two functions is not an indeterminate form, when the variable goes to not. All right? Yeah. So this question, yeah, when you answer this question, we use the background we discussed in the previous question. Yeah. So now we have very good preparation. Yeah. When the variable goes to infinity, yeah, then we cannot use the Robitas rule to calculate this limit. Correct, right? So this is easy answer. Yeah. Because the first condition, the limit, the ratio of two functions must be an indeterminate form. Otherwise, yeah, do not apply it. Yeah. So for this point, some students, they may forget this checking step. Yeah. It is pretty common. Yeah. Many students, they can only memorize the Robitas rule, limit of the ratio of two functions equals the limit of the ratio of their derivatives. They just memorize that formula. They skip the condition part. Yeah, it is pretty common. Yeah. Then they apply it directly, then they could get a wrong answer. If you do not check the condition, you will get a wrong answer. Yeah. It is pretty common. Yeah. All right. Yeah. All right. Yeah. So that's the question number 8. Yeah. And then we finish our video B.4.